Hello, today we're going to talk about graphing quadratic functions, and a quadratic is where we have a function and we have the highest power on the x is 2. So x squared is the highest power that we're dealing with in our function. Now quadratics are something that we have done lots of maths with before in algebra, and it's important that we recognize when we've got a quadratic. So when we have something squared and then the letter and then a number, that's usually what a quadratic looks like. And if we want to graph a quadratic in a particular domain, what we're going to do is exactly what we already know for graphing. We're going to draw a table. So we're going to start off by writing our x values and then our function. Y is equal to 2x squared minus 3x plus 1. And then we are going to have our values of x and y that we're going to use in order to draw our points. That will form our function, our graph. Now, we need our different values for x. So here we can see x goes from minus 1 up to plus 3. So that's going to be minus 1, 0, 1, 2, and 3. So what we're going to do is start off with y is equal to 2. The x always goes in, the thing we're substituting into x always goes in brackets every time. Minus 3 by minus 1 plus 1. And we put that into our calculators and we get 6. So our first point is going to be x is minus 1, y is 6. The second point is going to be 2. I'll put 0 in our brackets this time. Plus 1 is equal to 1. So we get 0, 1 is our second point. And I'm going to fill in the other ones and come back to you. So now we have all of our table filled in, and all we've done is put in our different values for x, put all of this into the calculator exactly as we write it, and we'll get out our values for y. So now we have our x's and our y's, we're able to start drawing our graph. And one point to remind you of, just before we get into that, a reminder that we could have been given this graph with, instead of y, we could have been told it was f of x was equal to 2x squared minus 3x plus 1. And that would have meant exactly the same thing. And so would a f colon x goes to 2x squared minus 3x plus 1. So we need to be familiar with all three meanings and the fact that these two mean the same thing as y. They're the same thing for our y coordinates here. But let's get into drawing things. Our first point is that x is minus 1, y is 6. So we start at the origin, always start at the origin, and then go in the door and up the stairs. In the door minus 1, up the stairs 6. That's our first point. Next point is 0, 1. So in the door 0, up the stairs 1. Next point is 1, 0. So we go in the door 1, up the stairs 0. Next point is 2, 3. So start at the origin, in the door 2, up the stairs 3. And our last point is going to be 3, 10. So start at the origin, in the door 3, up the stairs 10. Now this one we have to actually draw in freehand. So what we're going to do is, you can see that this is definitely not a straight line. The general shape of it should actually be a smiley face. So that's the general shape that our function should be. So smiley face. And the way that I know that is because it's a positive quadratic. So if I have a positive number in front of my x squared, if I have a positive number in front of my x squared, that tells me that I'm going to get a smiley face type graph. It should look like a smiley face. If I get a negative number, say if I got y is equal to minus 2x squared minus 6x plus 2, if I got something that had a minus x squared in it, then I would end up with a sad face. So positive, smiling, negative, sad face. That's the general shape. And I know that going in now, so I know what general shape I should have. And I'm going to draw in my curve in blue, and I'm going to try and draw a reasonably even curve in between my points. So this is our curve. So again, it's not drawn with a ruler. We do not use a ruler to draw straight lines between our points if it's a quadratic type function. We draw it in freehand, and we have to put in as much of a nice sweeping curve into it as we are able to draw. We don't have to be artists, but we do want to try and have a bit of a curve to it. Now, when we have this drawn in, there's a few questions that we might immediately ask, or that you might get asked in an exam. We have the roots of a function would be where y is equal to 0. So we have roots that we talked about before would be where y is equal to 0, or another way of saying that is where we cross the x-axis. So cross the x-axis. Well, what would be the roots of our function here, of our smiley-faced function, our positive quadratic? Well, we can see very clearly that one of our roots is going to be at x is equal to 1, and we actually have that as one of our points. Sorry, x is 1, y is 0. So this is going to be a root. This is what it looks like to have the coordinates of a root. X is 1, y is 0. The fact that y is 0 tells us this is a root. So one of our roots is at x is equal to 1. Now the other one doesn't cross an integer. It doesn't cross at a nice point. So we kind of have to just make a judgment call as to where we think it crosses our line. So it's somewhere around here. And I'd say that's about halfway between 0 and 1. So I would estimate that x is something approaching. So squiggly equal sign means approximately equal to a half. So the funny thing about our quadratic is we can see that it has two roots. Our blue line crosses the y-axis at crosses the x-axis, I'd say, at 2 points. So often, not always, but often, a quadratic will have two roots. It will cross the x-axis at 2 different points, at 2 different values of x. So this would be the roots of our quadratic. And that is the main thing that we need for now. So the core work is still drawing our table with all of our x values that we get from the domain. We sub in our x values in brackets into our functions and get our coordinates. And then we can plot those coordinates, and we know with a quadratic we're going to do a curved line instead of using a ruler between our points. And then we know that we can read things like the roots where we cross the x-axis off of our graph when we have drawn it.